Mr. Callan here to help you with Chapter 2, Lessons 3 and 4. Today we're going to be discussing, you guessed it, decimal products. Now hopefully you remember product being the key vocabulary word for multiplication. Before we carry on, go ahead and pause, check your homework answers, come on back when you're ready. All right, ladies and gents, today, multiplying decimals and using a shortcut when you multiply by powers of 10, so multiply by 1,000 or 100 or 100,000, I'm going to remind you that you've already been multiplying whole numbers, and I'm going to guess that many of you already learned this lesson as well, multiplying decimals. Naturally, we're going to be using these skills with equations, and when it comes to powers of 10, you're going to learn something called scientific notation at some point, which is a different way of representing number. Onward we go. Pause your paper, please. Whatever the date is, go ahead and write that down. Whatever the assignment is, pause your paper, copy what you need, come on back when you're ready. All right, how to multiply decimals. I'm going to go ahead and work on a skill. I'm going to challenge you as a student to work on a skill. I myself as a teacher need to focus on this as well. And that's just to estimate. So for instance, you see that 3 7/77 awfully close to 4. 2 8/10, awfully close to 3. So naturally, 4 times 3, our final answer should be about 12, ladies and gents, about 12. Now, I know you already know how to multiply digits. 8 times 7 is 56. Carry the 5. 8 times 7 is 56 plus 5 is 61. Carry. So let me go ahead and just assume that you can multiply all those digits. The question will be, where will the decimal point go? Now, a couple ways to figure this out. Firstly is the most common method. People will count the decimal places. 1 and 2 and 3 all together on top means there should be 1 and 2 and 3 down below. Meanwhile, don't forget how to use estimation as well. Think about all the different places that decimal could be with the digits 1, 0, 5, 5, 6. Well, if the final answer must be close to 12, there's really only one that's anywhere near there. I would recommend, look, students with strong skills can use the decimal place counting method. Students with the strongest skills could use either method. They can count the decimal places, or they can use estimation and say, look, my decimal, if the answer must be close to 12, the only place that decimal really could belong is 10 and 556 thousandths. Pause if you need, rewind if you need. Meanwhile, practice. If you'd like, pause the video, work these out, and then come on back when you're ready. All right, you can multiply digits. So 7 times 6 is going to be 42. 19 times 7, 133. But where should the decimal point go? Well, in this case, we have 1 and 2 and 3 places. So the only number that would make sense here is 42 thousandths. Meanwhile, take a look at the right. 1 and 2 and 3 places. So the only number that would make sense here is 133 thousandths. Now go ahead and pause for just a second. Look at how those problems are similar. Look how they're different. Clearly they have different numbers, okay, although they do both have a 7. What's interesting with the problem on the left, all 3 place values are at the number on the top. Problem on the right, there's only 1 decimal place on the top, and there's hundredths, 2 decimal places on the bottom. And yet, again, a major similarity. They both have to be moved 3 times. One other similarity, if you were to estimate, 7 thousandths is awfully close to 0. So the final product should be close to 0. Well, that makes sense. 42 thousandths is not a lot of money. Meanwhile, 1 and 9 tenths, awfully close to 2. 7 hundredths, again, you could round that to 0. To remind yourself that wherever that decimal point goes, 133 thousandths, yep, that's awfully close to 0 as well. So, a lot of similarities and a lot of differences with those problems, but I would argue there's there's more similarities. Onward we go. Pause your video. Come on back when you're ready. Multiply those out with the digits. Put the decimal place in. In this particular problem, there are 1 and 2, so 1 and 2. Hey, just a heads up, some of you like to put a 0 in. Others of you cross off the place value when you're ready to multiply the 3, the next place value. I don't care how you do it, but make sure that you mark that place value and don't put the 4 underneath the 2. Let's go ahead and crank it up a notch with some algebra. Here, we're going to use mental math skills to evaluate each expression. Now, please note that when I substitute in 2 hundredths for A and 5 wholes for B, a reminder, please, if there's no operation, if you don't see an operation in the middle, there still is an operation, and it is multiply. Now, here's what I mean by mental math skills. I shouldn't need to come off to the side and actually 2 times 5 is 10. Meanwhile, we have 1 and 2 decimal places, so there should be 2 decimal places for the final product. Now, you may put the 0 in the hundreds place if you wish and say that your answer is 10 hundredths, but notice that 10 pennies is the same as 1 dime. 10 hundredths is the same as 1 tenth. The extra 0 is not necessary. Onward we go. 2 times B, which is 5, times C, which is 1 and 4 tenths. But grouping symbols means we take care of that first. 2 5s is 10. Now, ladies and gents, 10 14s is 140, but yes, there is one decimal place here. So instead of 140, we should be able to mentally say, all right, if 10 14s is 140, one decimal place, mentally, you're moving that over to become 14 wholes. Carrying on, A times B, and then add C. Now, A times B, we've already done. 2 hundredths times 5 is 1 tenth. And from here, I would argue that you should be able to mentally, without going off to the side and lining up your place value, look, 1 dime, 4 dimes, 5 dimes, along with 1 whole and 5 tenths. Now let's wrap up with some more mental math skills, and this is a shortcut for multiplying by powers of 10. Anytime you multiply anything by 1, you're going to get itself. But what about those decimal places? Well, when you're multiplying by powers of 10, you really just need to move the decimal point to the right because you're making it larger. The number of zeros there are. So when I'm looking at 10, 10 is 10 to the first power. And so we're going to move that decimal point 1 time, 1 0, to make a final product of 27 wholes and 5 tenths. Now in this case, if we were multiplying by 10, we'd move it 1 time. But this isn't just 10, this is 10 times another 10. So let's move that decimal point not once, but twice to make a final product of 275. No, you don't need that decimal point. I'm just putting that there for effect so that you see it moves 2 places to the right. 2 and 75 hundredths times 1,000. We don't just change it once. We don't just move it twice. We'll move it 3 times. And of course, if there's no digit there, we'll fill it in with a 0. Again, no need for the decimal. I'm just putting that there for effect. Think about all the work that that will save you, ladies and gents. 2 and 75 hundredths times 1,000. 0 times 5, 0 times 7, 0 times 2, hold your place value. 0 times 5, 0 times 7, 0 times 2, hold your place value. Okay, Mr. Callan, I get it. 0 times 0 times 0. So, okay, hold the place value. And then we get the 1 times 5 and the 1 times 7, the 1 times 2. And by now you're getting kind of annoyed. 1, 2 place values, 1, 2 place values. So all that work gets crunched down into move it once, move it twice, move it thrice, move it 3 times. And that, ladies and gents, is a powerful shortcut. All right, back to your work. Remember, please, page 35, 20 to 39, you must show, after you write the directions, write the problem, show your work, write an answer. But For page 37, 29 to 47 is no work. You should be doing those mentally. So yeah, write the directions, write the problems out, but then go straight to the answers. Now 48 to 55 all returns back. Problem, work, answer, problem, work, answer. All right, folks, that's what I got for you. Let's go and let's grow. Have a good day.